All right, welcome back. Good morning, good afternoon, good evening. This is the Architecture Track. Thank you for joining us here on day two. We're excited to have you. We've got a lot of great presentations in front of us. Up next, we're going to talk about Spring Cloud Gateway and the API Hub. Now, I just want to remind everybody, we've got the join the discussion link there, so go ahead and hop into the Slack channel associated with this and start having some conversations. And then afterwards, we will have the Zoom Q&A room where you can continue to engage with this particular set of material. So without further ado, I'm going to go ahead and turn it over to a couple of my colleagues, Alexey and Gareth. Gentlemen, take it away.
All right. Thanks very much. Thanks for coming and joining our talk, everyone. So this is about Spring Cloud Gateway and API Hub for VMware Tanzu. I'm Gareth Clay. I'm one of the developers on the Spring Cloud commercial team.
And my name is Alexey Nesterov. I'm also one of the developers from the same team.
All right. Let me go ahead and bring some slides up. And let's get going. So first thing, just a quick thing to say, we're going to be talking about some stuff which is still under development and future looking, so things may change. And with that out of the way, let's get going on some background. So we can't get too far into describing Spring Cloud Gateway for VMware Tanzu without first describing what Tanzu application service is. So I'm guessing that a lot of you could be using it already, or you'll have heard about it. But just for anyone who hasn't, let's go through it quickly so then we can see how it relates to Spring Cloud Gateway. So Tanzu Application Service is VMware's platform for modern application deployment, and it's built on top of Cloud Foundry. It's built to let developers go fast by letting us focus on application development instead of all that other stuff like provisioning infrastructure and networking and security that we all know needs to happen in order to run apps in production. It does provide a nice graphical UI over everything, so you can see what's going on. But most of the time, once you get into it, you'll interact with the platform using the CF command line client. So given that and your application source code or a container image, you can run the CF push command. And when you run that, magic happens in the platform and your app will appear running in the cloud at scale if you want. And the magic within the platform is definitely one for another talk, but just know from a developer point of view, this is really easy to get going with. Alongside applications, another important part of the platform is integration with services. So Tanzu Application Service presents services to developers through a browsable marketplace. And with the CF create service command, you can create instances of those. And those services could be databases, they could be message queues, or in our case, our Spring Cloud Gateway. And then the last step is to connect our apps up with our services. And that's done with the CF bind service command. So when an app is bound to a service, it's given the URI and any credentials that it might need to be able to access that service. And it's also a chance for the service to learn about the app if it needs to. So that's a quick run through the platform. Let's talk a bit about open source and how the commercial product differs a little bit. So Spring Cloud Gateway for VMware Tanzu is our commercial gateway product, but it builds really heavily on Spring open source projects. So we really just want to explain the difference. In particular, we're making use of Spring Cloud, Spring Boot, Spring Security, and Project Reactor. And under the Spring Cloud open source umbrella, there's a project called Spring Cloud Gateway. And in fact, that's exactly what we're packaging in Spring Cloud Gateway for VMware Tanzu. So on the face of it, they sound like really similar things, but they're actually quite different. So the open source Spring Cloud Gateway project is a toolkit for building your own API gateways, just like Spring Boot is a toolkit for building your own modern Java applications. So if you wanted to build an API gateway for yourself from scratch, then the open source project is the way to go. But if you're up and running apps on Tanzu Application Service, then we've done that work for you already. The commercial Spring Cloud Gateway for a VMware Tanzu product takes no developer effort to get up and running with because we've integrated it into the service marketplace. So you can be up and running with Gateway just by running cf create service. And on top of that, we've added extra features, security, network configuration, and some other platform integrations that we're going to get through talking about in the rest of this talk. Okay, so that's the groundwork out of the way. So let's get into some detail on Gateway itself. And let's start with a bit of the rationale behind API gateways. So the promise of microservice architectures is supposed to be that you can go fast and change things quickly, creating, updating, deleting microservices to build this mesh of small, easy to understand components. And that's all great until you try to expose it to the outside world. So taking this example, let's say we've got a desktop or mobile client, and that's talking directly to some backend services. Say we're in the process of decomposing a backend down into microservices. So we've got one microservice, app1 here, which is serving API1. And then let's say we've got some legacy monolithic application, maybe sitting on a VM somewhere, and that's serving API2 and API3. And we want to continue to decompose that monolith by breaking out its API2 functionality into a new microservice. And we'll call that app2. And now immediately we have a problem because now I need to update my client applications. So you can see how this gets to be painful. So what we need is what we always need in software engineering, which is another level of indirection. And that's where API gateway comes in. So we can let our gateway present a solid, stable API to the outside world and provide flexible routing to our backend, which gives us the freedom to change whatever we like. And aside from the routing of traffic to our microservices, in order to keep that external API stable while things change on the backend, we might want to be able to adapt the requests or responses that flow through the gateway in some way. And to protect the backend, we might want to add security or impose things like rate limits. You get the idea. So in order to do any of these things, clearly we're going to need some kind of configuration for our gateway. But Spring Cloud Gateway is built for developers. And so we want to make that configuration super accessible, self-service, and as quick and easy as pushing apps and creating service instances. We definitely don't want you to have to go off and raise a support ticket to get this kind of thing done. So let's take a look at how that works. So the way we configure Gateway's request forwarding is through a list of rules that we call routes. And routes can be broken down essentially into three things: a set of predicates, a set of filters, and a destination URI. The predicates are a set of tests that tell Gateway whether a given route applies to any given request or not. So when a request comes in, all the routes get tested until a matching one is found. Or if there's no match, then we'll just return a 404 response. Once we found a matching route, then we might want to apply some kind of behavior to the request before we forward it on, or to the response that comes back. And that's what filters are for. And Alexey's going to go into those in depth a little bit later on. And then finally, we have our destination URI, which determines where we're going to send our request on to once it's been through any filters. Okay, so now we know about routes, we can take a look at how to create an instance of the gateway on Tanzu Application Service. So like we said before, Gateway is integrated with the platform's service marketplace. So just like any other service type, you can create an instance of Gateway using the cf create service command. And the arguments there are p.gateway, which is the service marketplace name for Spring Cloud Gateway. And then we've got standard, which is the type or plan of Gateway. And there's actually only one plan supported at the moment, so that's an easy one. And then lastly, my gateway is just the name that we're going to give to this service instance. So that's super easy. And if you run that, then in a minute or two, you'll have a gateway up and running. But that gateway won't have any routes by default. So there are a couple of ways to add those. And the first way is we can optionally provide a list of routes that will be configured in the gateway right from the start. And that's done using this JSON configuration that's passed in with the -c parameter to create service. So here we're defining a single route, which says for any GET or POST request that hits our gateway, that has a path that begins with /a, then route that to example.com. And then we have this strip prefix filter with a value of 1. And what that's saying is just drop that first component of the path. So rather than path beginning with /a, it'll have that stripped off when it's forwarded to example.com. So that's a fairly simple configuration, and we've shown it in this sort of verbose format that the open source Spring Cloud Gateway understands. But in the commercial product, we've actually taken some steps to try and simplify this a little bit. So here's what it compresses down to. So what we found is that the path and method predicates are so common that we've just brought these up and made these top-level configuration items. And same with strip prefix, that value of 1 is so common that if you don't tell us otherwise, we'll just apply that for you. And so when you run this command, it's going to be handled by our service broker in the commercial product. That's responsible for the integration between Spring Cloud Gateway and Tanzu Application Service. And in response to that, the service broker is going to go off and deploy a new gateway application for us. So each gateway service instance is backed by an application on the platform, and that's just like any other app. So you can always go and take a look at it and check its logs and that kind of thing. And we've even made a plugin for the CF-CLI, so you can get the logs directly by using the gateway service instance name rather than having to go in and find the app. So in that last example, we showed a route with a URI that was set to an off-platform destination, which was example.com. But most of the time, you'll be configuring Gateway to route traffic to applications which live on the platform. And when you're doing that, things become easier again because we can lean a little bit more on the platform and take advantage of service bindings. So you'll remember that service bindings link applications to service instances. So in this example, we're making use of that binding metaphor to add a route to our gateway, which will direct traffic to an application called MyApp. And you'll see that we don't need to specify the URI this time because we're able to just ask the platform for that. And then if you want to remove this route, then there's an equivalent partner command, unbind service, that'll take the route away. But there's a little bit more going on behind the scenes that is less obvious than just configuring the routes. And that's to do with how we set up networking. So every app running on the platform can actually have more than one URI mapped to it. And those URIs can either be external or internal. So the external URIs can be accessed from outside of the platform, whereas the internal URIs can only be accessed by other apps running on the platform. And only then if there's an explicit container-to-container network policy which allows those apps to talk to each other. So when you bind an app to Gateway, as well as setting up the routes, we'll configure container-to-container networking between the Gateway container and your application's container. And then we'll send traffic to your application via its first internal URI. So just to visualize that, let's take an example app which has both external and internal URIs and look at the different ways it can be accessed. So here we've got external URIs in green and internal URIs in blue. And so the obvious route to this application from outside the platform is the direct one. So app one has an external URI, so it can be accessed directly. And then if we bind it to Gateway, then we'll also be able to access it via the Gateway. So if we make a request to the Gateway's external URI, as long as the request matches the route for the bound app, then the Gateway will forward that request to the app using its internal URI over the container-to-container network. And then lastly, any other apps from within the platform can also access App1 via its external URI. They'd only be able to access it via the internal URI if you were to explicitly set up a network policy to allow that to happen. So we haven't shown that here. So the real benefit of Gateway's automatic container-to-container networking configuration comes in when you want to completely protect an application and make it only accessible via your gateway. So this is an example of another app which only has an internal URI. So again, on binding, Gateway will configure that container-to-container policy such that the gateway can reach the application via its internal URI. But that's now the only way to reach this application. It can't be accessed directly from anywhere else. And what this means is that you can start to delegate responsibilities to the gateway without worrying about being circumvented by some other route. So for example, you can delegate things like single sign-on or rate limiting to gateway without having to implement those features in every single backend app. And we're going to take a look at how to do both of those things a little bit later. The other benefit we get from using the container-to-container network is that we get decreased latency compared to the sort of hairpinning route that we have to take out of the platform and back in again via the routing tier, which is what happens when we go via the external URI. Okay, so that's setting up routes. Routes obviously aren't set in stone. Chances are you're going to want to change them over time. So how to do that? So if you want to change any of those static routes that you might have added at gateway creation time, you can use the cf update service command and pass in a new JSON routes array. And that just works in a really similar way to the cf create service command. So that's pretty straightforward. We've seen binding and unbinding as one way to modify the dynamic routes that point to applications that are running on the platform. But we also wanted to build something that's a little bit easier to code against. So those routes can also be modified via a REST API. And we're just showing an example of that in this curl command at the bottom of the slide. So you can modify those routes by making put requests to the routes endpoint for the app that you're interested in. All right, and just before I wrap up and hand back to Alexey, let's just have a quick look at the list of predicates that we're supporting. So we've seen path and method already and how those are configured with a JSON block. All of the predicates are configured in the same kind of way, just using JSON. It's just the content varies slightly depending on the configuration that's needed. So we've got after, before, and between, and those all perform tests against the time that a request comes in. So those can be really useful for doing cutovers to different services at different times, or maybe scheduling maintenance windows where you might want to fall back to different service implementations on the back end. Then we've got cookie header and host predicates, which are pretty self-explanatory. They let you check cookie and head values. We've seen method and path already. Those are joined by the query predicate, which lets you test against the query parameter parts of URIs. Remote address matches against a list of address ranges. And then the last one, weight, is interesting because that operates on groups of routes, and that supports weighted routing, so balancing traffic across a group of routes. So all of these are supported in the open source Spring Cloud Gateway project, and they have really in-depth documentation into each of these. So if you want to learn more in any of them, then that's definitely the place to go have a look. And with that, I'll hand it over to you, Alexey.
All right, thanks, Gareth. Yeah, so let's talk about filters now. So as you remember, every route is defined as a combination of predicates as a target URI and a set of filters. And filters, actually, unlike the name suggests, they don't filter anything. Instead, filters are basically a mechanism that allows you to do things with your request or response. is similar to servlet API filters to some extent. So open source Spring Cloud Gateway already provides you quite a few filters actually you can use for your root definition. And it's pretty standard, like what you can expect from API Gateway is you can modify the headers, you can add or remove headers from the request or from the response, you can map values, you can inject security headers into every response from your gateway. You can also, of course, rewrite path using extracted segments or prefixes if you want to. You can send redirects or pretty much any status code back to the user. You can introduce retry or circuit breaker logic in your API gateway, so your application don't have to deal with that, and many more basically. So all of these are available in open source version and in Spring Cloud Gateway for VMware Tanzu as well. And you can find documentation for all of these online in the reference documentation for Spring Cloud Gateway. So I'm not going to talk too much about these open source filters, and instead I'm going to focus on what Spring Cloud Gateway introduces on top of these filters, in addition to these filters, to make your life easier as a developer. And the first filter I'm going to talk about is probably the most demanded one, is single sign-on. So before I talk about single sign-on, I want to introduce another product, another service for VMware Tanzu. It's called, no surprise, single sign-on. And it's basically a sort of like authentication proxy. And with single sign-on for VMware Tanzu, you can configure access to one or multiple external providers, identity providers, using either SAML or OpenID Connect. And this basically lets you integrate with pretty much every single identity provider on the market, because most likely it will support one or another. So you can configure a set of providers plus some mapping rules if you want to into a configuration, which is called a plan in terminology of single sign-on. And then you can configure Spring Cloud Gateway or VMware Tanzu to actually integrate with this plan and then perform authentication for you. So to do that, basically, the only thing you need to do as a developer, you just need to put this SSO enabled true on your root definition. So this is per root, so you can have multiple roots, one with authentication, another one without authentication. That's totally possible. So when you have this root with SSO enabled set to true, and let's say when a user is trying to access this URL in a browser via the gateway, so what will happen? Gateway will check if there is a current session for the user already. If there is a session, if there is an active, even valid token for this user, and if there is no token or if there is no session, it will initiate this authentication dance using authorization code flow. So it will send the user to the login page where the users can actually either log in with their credentials, blank credentials, or they can pick one of the external providers. And once they're logged in, let's say if this is a SAML provider, this SAML provider the SAML token will be converted into JOT token, and a JOT token will be signed and issued to the gateway. And what I'm saying is there's a lot of things going to happen behind the scene. But all of this is going to be completely transparent to you. So all of this is going to be completely hidden in the gateway. So your application doesn't really need to worry about that. So when you just put this SSO enabled true on your root definition, it will automatically enable, as I said, authentication on this root, and it will trigger the login flow. And in addition to that, it will perform the basic authorization check. So it will basically check that the user is authenticated in order to access this root. And the beauty of this solution is the whole authentication process is fully delegated to the gateway. So your application is completely free of these concerns, and it doesn't even know about that something in front is performing authentication and authorization check. So this is pretty basic check. As I said, it just checks with SSO enabled. Gateway will only validate that the user is logged in. But sometimes you need to be more flexible than that. Sometimes you need to define more complicated rules, actually, in order to define authorization rules for your application, for your routes. And you can do that with Gateway as well. So in addition to SSO enabled, SSO filter supports scopes and roles parameters. So let's say if you define scopes on your root again, this is all root-based filters, so root level filters. So if you define scope on your root, in addition to just authenticating the user, Gateway will also check that the access token issued for the user by SSO actually has this accounts.view scope. And if, let's say, if the scope is not presented, it will result in 403 response back and no request will reach your application. In addition to that, you can also validate access to, you can also authorize users accessing your application based on the roles they have in external identity provider. And again, behind the scenes, there's quite a lot of things happening. So the group membership information will be extracted from the external identity provider, will be mapped into this, into the token, into the ID token. So a lot of things will happen behind the scenes. But for you as a developer, you can just say, okay, I want to allow access to /app1 to this route. I only want to allow access for users with role auditor. And that's it. So let's say if the user doesn't have this role in a list of roles, again, gateway will just return 403. So that's how you can configure not just authentication on your Spring Cloud gateway, but also authorization rules. And again, it's all in a gateway. Your application doesn't need to know about it. However, sometimes there are situations when your application needs to know about the current user identity. Maybe not for authorization reasons, because you can do it all in a gateway, but sometimes you need to know the user identity, maybe just, display username or something. And it's also possible. So you can enable token relay. You can set token relay to true on a particular route as well. And that what will happen in this case, for all the requests to this route, Gateway will do normal authentication, authorization checks, whatever it needs to do. And then it will inject a valid ID token from the current user session into the header into every request it sends to your application. So in all the requests your application receives from the gateway, you will find this authorization bearer token, and you can basically extract it and get the user identity from there, or pretty much any claim, any information available in the token you can use. So this token is already validated, is already checked by the gateway. But for better security and for the peace of mind, Gateway will also provide your application with a authentication domain, which is basically a URL of the authorization server that contains the public keys to validate the token. So let's say if you're using Spring Security, it's fairly easy to configure to actually fetch the keys, get the token, validate it, extract user into identity, and then just use it super easily within Spring application. But it's perfectly fine. It's doable in other applications as well, in other languages and platforms. So that's how you can basically configure security features as a single sign-on, authentication, authorization, and a token relay on the gateway. Before I talk about the next filter, or the next feature basically of Spring Cloud Gateway for VMware Tanzu, I want to mention the higher level feature of the overall platform is mutual TLS. So mutual TLS is basically, as you know, is similar to normal TLS, but in the mutual TLS, not just server has to provide a valid certificate, but the client has to provide a valid certificate as well. So they basically mutually authenticate each other. So this is already integrated into the platform, into Tanzu application service. So I'm going to talk a little bit about platform for a second. And the first component I want to mention is Tanzu application service Go Router, which is sort of like ingress for like all the traffic to the platform. So it receives all the traffic either from the public internet or from the load balancer. So let's say if you configure TLS termination on a load balancer, and let's say configuring mTLS between the load balancer and the Go router, it is doable, it's configurable, but for the simplicity, I'm just gonna consider an example where the TLS is terminated on the Go router directly, not on an infrastructure load balancer. So let's say that when a TLS is terminated on the Go router, and the client provides a valid client certificate on this connection. So then the Go router will actually, of course, validate the certificate as usual. And then when the Go router will send the traffic to any application on the platform, including Gateway, it will actually connect not directly to your application, but it will connect to a sidecar proxy running in an application container next to your app. And this is the Envoy proxy. And it will establish mTLS connection between Go router and this Envoy proxy. And it will establish mTLS connection using the set of certificates, which are automatically rotated. These are automatically updated. So you don't have to deal with that. It's just already provided by the platform. And that's a standard feature of the Tanzu application service. So in addition to that, Spring Cloud Gateway for TAS provides a similar feature. So when Go router sends the traffic to the gateway via mTLS and via Envoy proxy, Gateway can send traffic to your service, to your application, using Envoy proxy as well. And in this case, it will also establish mTLS connection between the gateway and your application. So basically, the traffic can be encrypted all the way from the client to your application running on the platform. So that's all out of the box. There's no need to configure anything. It just works. When you deploy it, it's just there. But what I want to talk about is about the extra validation of this client certificate. So, of course, the client certificate will be validated on every step, but sometimes you need to perform extra validations. So this is done using X forwarded client certificate header. So when a Go router receives the client certificate, it will base64 encode it and inject it into the request to the gateway. And then so the gateway can then perform extra validations. So the validations, let's say, you can check the common name and a fingerprint of this provided certificate. So you can just define on your root definition, you can define this client certificate header filter, and it will extract the certificate from the XFCC header. It will validate the certificate for you, so you don't have to do that. And then it can provide you, it can run extra validations if you want to. Let's say you can check the common name, matches what you specified in here, and you can also validate the fingerprint. So if the common name of fingerprint does not match, it will just reject the request basically, and with 403. So that's how you can use mutual TLS and perform extra checks on the client certificate using Spring Cloud Gateway. All right, so there was basically a set of security features. And the next one I want to mention is rate limiting. So open source version of Spring Cloud Gateway also provides you a rate limiting filter, but open source version actually requires an external state management solution. Let's say you need to deploy Redis, most likely it's going to be Redis, to maintain your state in case if you have a scaled out deployment of your Spring Cloud Gateway. So Spring Cloud Gateway for TAS actually takes another approach, and instead of requiring external dependency, instead, when you scale out Spring Cloud Gateway, it will form an in-memory data grid cluster, and it will keep all the information about the rate limits in sync between these nodes. So you can just, again, on your root definition, you can just put rate limit and then give it a value, and the value is a number of requests, comma, and a period of time. Let's say in this example, we have 100 requests over 1 second. And that's it. And the gateway will deal with the rest of it. So it will maintain the up-to-date rate limits across the cluster. So no matter which of the instances actually been hit by the request, it will apply the correct rate limits. So one thing to mention about the rate limiting is Spring Cloud Gateway uses leaky bucket token algorithm, and it uses greedy replenishment approach. So in this case, let's say it doesn't mean that the gateway will allow 100 requests in the next second. Instead, it will actually allow you 1 request every 10 milliseconds, approximately. So you need to keep that in mind. So this refresh of this limit actually is not over the period of time, but it's gradually restored over this period. And with rate limiting, I think that's the last feature I want to talk about in terms of filters. There's more features to talk about. So I'm back to you, Gareth.
Yeah, thanks, Alexey. So we've spoken a lot about features that really apply to individual routes, but we also have some features that we want to go through that sort of apply at the global level per gateway instance. And first of those is high availability, which Alexey's really alluded to with the rate limiting filter. But we just want to show you how this can be set up. So in a production scenario, you probably don't want to be running a single instance of that gateway backing application. As good as the platform is, and as resilient it is, and as good as it is at bringing applications back, should one fail, having multiple instances can really make all the difference between an end user seeing downtime or not. So for a production scenario, you probably want to be running gateway in an HA setup. And the way you do that is just by passing this count parameter with a value greater than 1 on CF create service or CF update service. And as Alexey was saying, when you do that, Gateway will automatically form the in-memory data grid, and then we can manage any state that needs to be shared between those backing application instances. Custom domains. So when Tanzu application service is set up, it's configured with two domains. We've got the application domain, which is where your apps are made accessible, and the system domain, which is where platform system components live. And then we use wildcard DNS to route requests made to those domains to the platform's routing tier. But there's nothing to stop you from configuring custom domains for your platform. So if you have a particular domain name that you want to use, you can set that up in DNS and then just add it to the platform with the cf create domain command. And we've integrated Spring Cloud Gateway with custom domains as well. So by default, every gateway instance you create will be given its own external URI, and that gets composed from the gateway service instance name and your platform's application domain. But if you wanted to use a custom domain, then you can just override that by passing in the host and domain parameters when you CF create service. And then following on from that, if you're serving web content, it's completely possible to have Gateway serving APIs from a different origin than your web server. And in that case, if you're calling APIs via Gateway directly from the browser, then it's useful to be able to delegate cause behavior to the gateway rather than having to worry about that per backend application instance. So you can configure global cause support using this cause JSON block and set up the types of requests that you want to accept from different origins. So these are all the available configuration parameters, but you don't have to specify all of these, just use the ones that you want. And with that, I think let's move on from Gateway for a bit.
Yeah, thanks. So we talked a lot about the gateway, but actually the title of our talk is Introducing Spring Cloud Gateway and API Hub for VMware Tanzu. So what is API Hub? Well, as the name suggests, it's basically a place where you can see all your APIs all together. So we talked about Spring Cloud Gateway a lot, and Spring Cloud Gateway actually helps the API developers, application developers to easily develop and publish the APIs and applications via the gateway. But on the other side of these applications, there are consumers, and the consumers actually they want to explore and find the available APIs they want to use in their applications, or they want to see the available endpoints they can use. And this is exactly what API Hub is for. So API Hub is pretty much work in progress at the moment. So API Hub, the purpose of that is you can aggregate information from multiple Spring Cloud gateways running on the platform, or maybe on the multiple foundations in the multiple environments, into a single, unified catalog of all APIs available in your org. And let's say on this page, we see an example of multiple gateways. So every tile on this page represents a gateway. And as you can see, these tiles, they have a human-friendly title and some description and basically link to the more detailed page of that. You can use search functionality on this page, so you can search for an API you're interested in. And this is all, again, this is automatically, so once you have your routes registered in the gateway, these all automatically become available on API Hub as well. So let's say if you go to one of these gateway instances, if you just click one of these View APIs buttons, we land on this page with more details about particular gateway. On this page, we can see a full list of routes, a full list of APIs actually registered on this gateway. And if you have multiple applications, all of them will be listed. All of them will be listed in here in this list. So, for every API, for every route, you basically see standard information like summary and some documentation for the API. You can see, of course, information about it like available path and methods. You can see a version number if available. But you also can see all of these features, all of these, let's say, security features we just talked about. Let's say you can see if SSO login is enabled for this route, or let's say if there are any authorization rules like required scopes, which of them are actually applied to this route. So you can see it all in one place, or let's say rate limiting rules also going to be here. And you also able to see, let's say, all the possible responses and the supported parameters by this route. And you can even click try it out button. And with that, you can send an actual request to the gateway, and then which will be proxied to your application, get the response back, and explore it, and then see what's available in there. And you can basically try APIs right from your browser. So that's how cool is that. But this is just the front end. What is even more interesting is the implementation of that. So from architectural standpoint, API Hub is just yet another application, and it aggregates information about the available APIs, about available routes from multiple gateways using OpenAPI specification. So it's not consuming the APIs spec directly from the gateway, but instead it uses the broker, but that's an implementation detail. But the key here is that all of these APIs displayed using OpenAPI spec. And this means that you can use your favorite tools that work with OpenAPI specification to actually do whatever you want with this, with the list of routes from on a gateway. You can generate automatically generate a client for a gateway based on OpenAPI specification. You can generate a documentation page if you want to. Basically, you can use pretty much any OpenAPI, any tool compatible with OpenAPI specification with our Spring Cloud Gateway for VMware Tanzu. And that's the beauty of that. So it's based on a standard OpenAPI spec. Another feature we're actually working on, and maybe a disclaimer, actually, this is API Hub is a work in progress. So there is no version you can get and try to play with it. But if you have any questions, if you have any ideas, how would you like to use it, or you just want to chat about it, just feel free to reach out, and we're always happy to talk about it. We're very interested in knowing how you see the usage of this API Hub. So the next feature of API Hub is we're exploring now and we're working on now is managing API keys for your APIs in your gateway. This basically just pretty much standard API keys features, but instead of actually managing the API keys in your application or even in your gateway, it's delegated to API Hub now. So in API Hub, as a consumer of this API, you can request a key, so you can generate a key to start using the API. And as a sort of like manager of this API, maybe creator of this API endpoint, you can also see all the keys issued for your particular API, for your particular endpoint, for a particular gateway. You can issue new tokens. You can revoke existing tokens. You can see some usage statistics on the particular keys. So basically, you can manage access to your APIs using this API keys functionality of API Hub. As I said, this is pretty much work in progress. Come talk to us if you have any ideas, or if you are interested in just using that, and if you have any ideas how you would like to use it. And with that, I believe we're ready to move on to the next part. The most exciting part is demo. So we only have about 10 minutes left, I think. So we're trying to keep it quick. Right. So for the demo, we're going to be using an application called Animal Rescue. You've probably already seen it at least a couple of times on the previous talks. And so we're going to be using it one more time. So Animal Rescue is a sort of like pet clinic. So it's a pet clinic as a sample application for Spring Boot. Animal Rescue is a sample application for Spring Cloud Gateway for VMware Tanzu. So it's also on GitHub. So if you want to have a look at this or try to deploy it yourself, you can always find it on GitHub. You can just go and see all the source codes and all the configurations we're going to be using. So we're going to start with creating a new Spring Cloud Gateway instance. So it takes a bit of time. So just for the sake of time, we created one already. And this is the command you can use to actually create a new service instance. So it's basically just a create service. And then you can provide a configuration file, which is just a JSON file, which is on the screen below. And in this configuration, you can configure your instance using all the features we discussed before. Let's say you can set up SSO plan for that. You can say, I want to use a plan called test, and I want to enable two identity providers for this SSO integration. We want to deploy only a single instance of the gateway. This is just a demo, so one should be enough. So we can configure which host we want to be running on. We also can configure documentation properties like title, description, documentation, and version. And this is what is going to be used by API Hub to display information about this particular Spring Cloud gateway. And we can configure a couple more parameters, but again, for the sake of time, let's just not stop there. So when the new service instance is created, what we can do, we can check the status of that by navigating to dashboard. So the dashboard is another feature of Spring Cloud Gateway, which we didn't mention, but we're just going to show it quickly. So when we navigate to the dashboard, we can see some high-level summary about the Spring Cloud Gateway we have deployed. And to access the dashboard, you need to be authenticated, of course. So you either need to have admin permissions on a platform, or you need to be a space developer in the space where the service instance is created to access the dashboard. But once you get there, you can see information about your instance. So you can see basically which the version of the Spring Cloud Gateway you have running, what's the base URL, the number of instances, documentation properties. You can see SSO plan, which is used for this particular instance. And you can see the list of routes. And in our case, it's empty. That's not good. Let's fix that. So let's push a couple of applications. So in our Animal Rescue demo app, it actually contains two applications. It's a backend and a front end. And we're using this manifest file to push both of them. So the manifest file in Tanzu world is basically deployment manifest. So we're pushing a front-end application, which is React single-page application. It's just the static files. And we're also pushing a backend application. And the backend application is a Spring Boot Java application. So one thing I want to pay your attention to is this roots section. So the roots section, we can define basically the roots for the applications. And for both of them, we only have one root. Well, every application has its own root, but they both are internal roots. So you can basically see that they end with .apps.internal. And it means this application is not publicly available on the internet. So you cannot just type this URL in your browser and access the application. It's not accessible outside of the platform. In fact, it's not even resolvable. The host name is not available. So to access the application, we're going to need to register roots. So while binding is happening, so the pushing is happening. So now Cloud Foundry actually building the container images and starting them, and registering the roots and doing all the heavy lifting. So we have them up and running. So to actually make them available on the gateway, we need to bind them to this service instance, to this gateway we have created. So to bind, we just provide an application name, gateway name, and we can also provide binding configuration. And the binding configuration contains a list of routes for the gateway to actually send the traffic from these routes to the application. So let's say in our example, we have for the front end, we have two routes, so which is a perfectly fine setup. So you can have multiple routes pointing to the same application. And let's say in our case, we have two routes, again, with some documentation properties, first of all. Both routes have this path and method specified. And what is interesting, for the first one, we have SSO enabled set to true. And we also have a set of filters configured for that. So once the once the login successfully completed, we want to redirect user back to /rescue. And the second one is not protected, basically. So the second one accepts all the requests that didn't match with the first one. So, and again, this SSO enabled is the key, basically, to trigger to start the authentication process with the application. So, okay, now the application is up and running. And if we refresh our dashboard, we should see that now it has quite a few routes registered. And this list of routes is aggregated list of routes from the front end and from the back end. All right, let's try to access the application now. So let's try to go to our gateway URL /rescue, which is our homepage. And in there, we should see our front-end application, our React application running, and talking to the backend application. And look at that. We have all of these cute animals displayed on the homepage. So now, when we see these animals, it's actually a response from the backend displayed by the front-end application. We want to adopt one of these animals, but we can't because we're not authenticated. So let's see how this SSO enabled works. And let's click the sign in to adopt button, which will just redirect us to /rescue/login. And this will trigger this authentication flow for us, the login flow. So in here, we're going to be using Okta to log into the application. But we can, of course, use username and password. So if you just click this Okta link, so now we actually, from the SSO plan, we redirected to Okta login page, which is our configured SAML provider. And when we log in, Okta will send back the SAML assertion token to SSO. SSO will generate a JOT token. JOT token will go back to the gateway. And here we are. For us, it was just SSO enabled set to true, and we can now see, we can now adopt one of these animals. Now we authenticated to do that. And that's how you can configure authentication for your application on the Spring Cloud Gateway. One thing to mention maybe very quickly is, let's say in our example, we see a username in the top right corner. So this username is actually supplied by the backend application. So the backend application also knows about the user identity. And this is configured using a token relay filter. So if we have a look at the backend application routes configuration, one of them will have who am I endpoint will have this token relay set to true. I think it's a little bit below. Yeah, set to true. And this means we can actually get the token and extract user identity from it. All right, so we're short on time. So let's quickly have a look at the rate limiting. So another route we have in here is /API/animals. And as you can see, we have this rate limit equals to 2 requests over 10 seconds. Let's try that. Let's try to run a benchmarking tool and see how many requests we're going to get. As you can see, most of these responses are 429, too many requests. Some of them are successful. Blue lines is a successful 200 requests. And this is basically how our rate limiting works. So none of these requests actually reach your application, and only the blue requests actually get to the backend. All right, and if you stop that and if you check the statistics on that, as I said, you may expect a small deviation from the exact number you have. Right, so since we only have a few minutes left, let's maybe go and have a quick look at the API Hub and just wrap it up. So API Hub, we also have it running already. So let's go there and see what we have. So we just pushed a couple of created a service instance and pushed a couple of applications. And this is our Spring Cloud Gateway instance running. So if you navigate and go to this view details link, we can actually see all the APIs from the front end and from the backend application combined in a single list of APIs. And we can even expand this, let's say, API/animals, and we can see all the parameters, all the potential response codes taking into account rate limiting. And we can even try that out. So if you just click this button, we can see this is the response from the backend application via our gateway. And I think in terms of demo, that's all that we have to demonstrate. So I think, Gareth, back to you.
Great. Thanks, Alexey. Let me just very quickly find our slides again. Going to share. So very quickly, what's coming next? You might have heard of this little project called Kubernetes. So Kubernetes support is the main focus of development for Spring Cloud Gateway for VMware Tanzu right now. And in particular, there are a couple of Kubernetes flavors that we want to integrate Gateway with. So we've talked a lot about Tanzu Application Service in this talk. And up until now, we've really been talking about the very mature version of that platform that runs directly on VMs. But you'll have seen in the keynote, Tanzu application service for Kubernetes is in beta right now. And that's going to provide the same CF push applications service marketplace experience as we've already seen, but running on your K8s cluster rather than on VMs. And we definitely want Spring Cloud Gateway to be a service offering on that platform. And so we're working towards getting feature parity there. But on top of that, we really want to offer Spring Cloud Gateway on top of any Kubernetes distribution or public cloud offering. And so that's what we're working on next. And with that, I think we might have just got in time. That's the end of our talk. So thanks very much, everyone.
Yeah, thanks for joining.
Outstanding. Thank you, Alexey. Thank you, Gareth. That was fantastic. As I was sitting here listening in, it was just these dulcet tones. I just kind of wanted to lean back, sip a cup of coffee. You know, it's just like listening to public radio. It was fantastic. Thank you, gentlemen. All right, folks, we're going to take a quick break. Get up, stretch your legs, fill up your coffee, or if it's evening, a beverage of your choice, and we will be back shortly with a little bit of spring boot action.